Hey everybody, we are live now. I was just getting some new music. I wonder if this is going to get us with a copyright. This is like my test of it. Just starting out with some nice music to start out right here. Let's head over to the main screen right here and let's do this. What's up, Andrew? Starting out with some 474 today. Let's see if this gets us hit with a Josiah. I'm sorry. You're my favorite channel, Josiah. Josiah Wilkinson, amazing pianist. Hasn't posted in 4 years. And I used some of his music for some of my intros, and I always credit him below the video. So Josiah Wilkinson, go check out. Let me type his name right here. Josiah Wilkinson. Go check that out on YouTube. Amazing YouTube channel. Giving him a shout out right here. Go check out Josiah's channel. Lots of covers. We'll see if Coldplay hits us. We'll see if Josiah hits us. We'll see what happens. I'm just doing that as a test right here in this video. I was like, I'd like to use that. Maybe I took too much of the music. Maybe Coldplay will be like, that's our song in a Stat 201 help video. Who knows? We'll find out what happens. We'll find out what happens with the world. Make sure. I think I've got chat mic has system. I'll turn off system. Trying to do all different things. What's up, Andrew? I already said that before, but let's go take a look at 3A. Was it 3A? Which ones did people want? 3A and 3B. They won't help with question 3 for 474. Question 3 for 474. So we should be down here. Sorry if the numbers are ever out of order. I think we're down here. Mackenzie, am I right? Which ones are you looking for? Do we have the numbers wrong again? So which one? Task 3 right here. I'm assuming you're thinking about task 3 classification. We're working with the purchase data frame right here. Contains a small part of customer database from a bank. Of interest is purchase right here, which tells us if the customer did or did not make a purchase at a major chain retailer in the following 30 days. Predicting variable includes visits, number of visits they had in the last 9 days, spent, how much the customer has spent in the last 9 days, percent closed, the percent of purchases the customer makes in general that are within 5 miles of their address, close set and close stores, which detail how the closest the nearest stores in the chains is to the customer, and how many stores the chains are within 5 miles of the home. So let's hear it. We are streaming live. Yes, we are. I think we are live. Everything's good. Let's try to predict right here. Let's try to predict purchase buy/no. We'll use the data as is, no scaling, no transformations. Since tree models don't need that, that's because when you think about a tree model right here, I one time I remember when I was first learning trees, if you take data and you kind of transform it, it doesn't change where the breaks are in the data. So if you have data that's really skewed and then you make it normal, all the data still has the same spacing. So tree models are about going between the unique values. So we talked about this during last class. We'll load up the purchase data. But when you have data, like if we have a vector of x right here, this is just kind of talk from what we did from the last class. If you have values right here for your x, then what will the tree try to do when it makes splits? The tree is going to try to split between 1.5 and it's also going to try to split at 3. So what it's going to do right here is it's going to see, is this a good spot to partition the data when making the split? And sure, we'll delete one of those ones. Or is this a good spot? So it's going to split it into partitions right here based on the x, or it'll split based on a categorical variable if there's a categorical x, but it doesn't matter if we transform it because we're talking about quantitative x's here. So there's no real need to transform it because you still have the unique values, and transforming them won't change the unique values. It'll just change the shape of the distribution, and the shape of the distributions with the trees here won't really matter. So what we're going to do is we're going to randomly split it into a 50-50% split using seed 2020. So we need to make some train.rows right here. Train.rows is going to take a sample from 1 through the number of rows in purchase. If I could type today. How is everyone doing? I don't see anyone in the chat anymore. We lost everybody. Where'd everyone go? And we're going to take 50% of the number of rows. So it's important to know what this code is doing. We always do a review of our code to make sure we understand what each argument does. There are 2 arguments in this code, the first and the second argument. The first argument, what's up, Timothy? So good to see you right here. Lunch break for Stat Nation. Let's do it. Mubot is still on. I never turned off Mubot last night, apparently. Didn't turn off the computer either. So stayed up all night. No, I really didn't. Argument 1 right here is what we are sampling. And argument 2 is how much we're taking. So we're taking 50% of the number of rows, and you can see right there, that's how many we're taking. I believe it rounds up. You can see right here, it did not round up. Ooh. And then the other thing we're taking is from these numbers. So we're taking 50% of these numbers, and what you want to do is you want to run this as a chunk because then you will control the randomness. By running set seed right before it, that sets the randomness, and then you have the random rows are created. So this just creates random numbers. We haven't taken the rows yet. To take the random rows, we're going to store into train. We're going to go to the purchase data set. Always type about 3 letters, and you can get your autocomplete going. And then you can type train rows, and here we are. How do you know when more homeworks? Yes, I hope soon. We've been talking to the graders, and they should be on top of it. They're supposed to only take a week, but let me make sure. I'll check right after this. Timothy, send me an email, and I'll double check to make sure everything's released. That's released because they're supposed to release them when they do it, but sometimes I have to go in and actually release them. So hopefully, I've watched all your Stats 1 videos this semester. Just decided to finally stop by. Oh, Taco, thank you so much. Hey, we really appreciate that. Any questions you have, Taco? Are you? I don't know if you're a 201 student, a 320, a 474. It looks like 201, but so good to have you. Thank you. And we're gonna be playing a Kahoot at the end of the semester. So join the Kahoot, win a Mad of Tacos. That's Soccer Taco. Best place to go to Soccer Taco in Knoxville if you haven't been there. Chapter 17 homework. I need help with both of the conference journal questions. You got it right there, Dan. We'll be working on that soon. Yeah, Timothy, I'll see you tomorrow morning. Excellent stuff. Taco, I'm really glad that these have helped out. You know, like I do a lot of the problems, but I want people to kind of go through and understand what's going on. And yeah, no, I love that. I like people in here being like, hey, these videos have helped me, because that's my goal. That is my goal. And we just did the code right here. We have random training and random holdout. I have so much stuff stored in here. Based on the distribution of class of purchase, what would the model predict for the naive? So what is the naive model? Here's how. So this is an advanced topic here. So if you're 201, don't worry, it's not that complex. Let's say you go to an Atlanta Braves game. You talk to a random person. Who do you think they'd want to win the game? Who do you think at an Atlanta Braves game, who do you think a random person would want to win the game? So in an Atlanta Braves game, who do you think? The Braves. Because why is that? I bet, Jake, why is it? Why would a person at the Braves game, a random person, be more likely to say the Braves? So you go to an Atlanta Braves game, you say, who do you think's going to win? Exactly. It's the home team, and it's the what level. So whenever we do, so everyone's perfectly on track. So categorical variables use the majority level and predict everyone is this. So a categorical variable is going to use the majority level right here. So let's go to the training data and do a summary of train purchase. And are we going to predict everyone buys or does not buy? We're going to predict buy or no for everybody. What would we predict right here? Would we predict buy or no? I'm looking at the rest of the question. Use the majority level. All right, I wrote that. What is the estimated accuracy of the 9 mil on the training data? We're going to predict no. Nice job, Alyssa right here. Oh my gosh, my brain's just broken. Let's divide this by the number of rows in purchase. And there we go. And then let's take this. You don't have to do all this, but I like. There we go. There's the, oh wait. Why did it not work? Oh, ha ha ha. There we go. There we go. What I did is I divided it by the number of rows in purchase, but we want by the number of rows in train. And there we go. Here is down to 2 decimal places the accuracy for the model on the train data. You could do the accuracy on the holdout. It doesn't ask it, but it's easy enough to just go here, change this to holdout. And there's the accuracy on the holdout. So the naive model would predict no for everybody. So this is the accuracy on the naive model and on the holdout on the train, the accuracy with the naive model on the train and on the holdout. Set up fit control right here for k-fold 5 validation. We have most of it filled out right here. I see it's no fun when we fill it out. Oh, what you can do is you can highlight all the code and hold Command-Shift-C right now. That'll unblock comment. Ooh, the way we block commented it is not letting you unblock comment. Ooh. Oh, it's because that space is it? So let's try this. I could have just deleted them in that amount of time, but you can do block comment with Command-Shift-C. Thank you, Connor, who taught me that. I think it was Connor or Andrew, one of the two, taught me how to do block comments, which is a really nice thing. So we have method. This is the method for the cross-validation, which we're going to use cross-validation method. We have number of folds we're going to put in this. The number of folds here is going to be 5-fold k-fold cross-validation. So we go with here with 5 folds. and we go to class summary. The class summary is going to be to class summary, which because we're doing a binomial two-level categorical variable, class probs are true, and here we go. Now we just have to make our model. So the format for this, I'm going to delete all this just because I'm going to practice right here. It never hurts to practice writing everything out. Is y tilde x comma data equals to start. So we need to do purchase tilde dot, and that means all the x's. I usually put comma data equals on the same line, and we're going to use the train data. So y tilde x comma data equals comma method equals, and are we making what are we making? Logistic regression model, GLM. So, and I don't think we're doing regularized logistic. We are fitting on, we're fitting the metric accuracy was written on the results because we're using ROC. That's due to this portion of the code right here. It's important to know what each portion of the code does. Now we need to go here. Tell me if I missed anything. We need to do train control. Always use the autocomplete. It's easy to make a mistake. Train control. Ooh, I might have made a mistake. Should be, oh, it's TR control. TR control. Uh-oh. Brian's brain broke and made an error. I'm going to cheat. I'm going to go back and look because I know we have it up here. TR control. It is TR control. So many little things. I hate when autocomplete doesn't jump in. It is TR control. So is that going to autocomplete as an argument? Really? That's not fair. That's why I usually copy paste these. There we go. And now we need to do pre-proc. Is library reg caret not on right now? Because we're not getting any of these. Pre-proc equals concatenate center. Oh, it doesn't have a capital C. I need coffee, everybody. I need coffee. Don't want coffee. I need coffee. And that should do it right there. That should, is this making sense, Alyssa? Right here, is it making sense how we're making these models? How, what each argument means inside of it? Because you don't, sometimes I just practice because I could have filled out the blanks, but then you also need to know what you're doing. Does it make sense? Awesome. And the GLM net results, the accuracy, ooh, accuracy is not that great. And so it is optimizing on AUC. We are getting the accuracy right there. We could find the AUC ROC for this. If you want to look at the AUC ROC of it, let's go here. It's F20. So let's see. I got so many documents open. So see, there's the pre-proc right there. Let's go to AUC. Here it is. I always like just taking this code. We can analyze this code here in a second, but homework, I just saw it. I think, which one were we on? Oh my gosh. Never have this up. Well, sure. Let's go right here. So at the very bottom, the response is already filled out. So I was using it as a check figure, but my results are super slightly off both ROCs. Let me look at my ROC for this. Let me make sure I'm using the right one right here. Is this the one? I think I was using this one. Okay, here's where I was at. A lot of documents. Okay, so when we do the ROC right here, let's see what the ROC is. It tells you what the ROCs are, right? So response, logistic regression model is better. Looks like we left that in. So let's see right here. So we have the differences in ROCs, and let me find my one ROC and see if I get something similar. We might need to send out an announcement. So the holdout, how does it do on the holdout? We're not using the k-nearest neighbors model. We're using the GLM. And so new data, we have everything right. We just need to go here, purchase. And I think that'll do it. 6298. Is that what this says right here? Is that what you're getting? Alyssa, is that what you're getting? Might send out an update. The code is running. As I got 2 for my, you got that right there. The code's running, but I'm not getting any results. What are you seeing, Mackenzie, when you run it? Like, what are you seeing when you run it? I'm going to leave the other one here. But the estimated AUC right here, we could do the AUC on the train. What are you getting? So there's on the train. That's the AUC on the train right there. We should, let me check this right here. There we go. There's the ROC and AUC and the standard deviation. So we get the ROC standard deviation right here, 0.6209, but that's not on the holdout. Never mind, it ran. Oh, okay, good. And we can do it on the holdout. I think I've got, just want to make sure I have the right model stored in here. And 0.6298. Parameter ROC, okay, wait. Oh my gosh, 0.6595. Is that for the GLM model? Is that for the GLM? Because I'm getting very different results for the GLM. We could do some checks right here. Let's see. So my GLM net results are an ROC of 0.620. This is for this. Do this right now. Tell me, does your train... Oh, I bet I know what it is. Let me try something here really quick before I do this because I have a good idea. A lot of the issues we have relates to this. Okay. Let me run this. We don't need this. Yeah, it's removed for now. Wait, let's bring it back. Let's do that. Guess we need it. Okay, so let's try this. And let's see what we get. Ooh, that's different from you too. And do this. Tell me what you get when you run this code right here. Let's go to row 1. I get row 17935. 17935, let me write that down here. 17935. And let me run this. That still gets that. Is it the same one? Oh, because no 9998. No 998. Why would we... Send me your thing. Why would we be getting different results? Hey, Brian, I do not have any questions, but I was glad if you can review any important topic you think of. Oh, yeah, we can do that. We're going to do some 201 next, and we can do some review of 320. What row are you getting, Mackenzie, for your... What row are you getting? I don't know why it would give... If we're all using this. 15... Okay. What is your... Are you running the set seed? Do this right here. Run... So... Oh, there's where we're using the set seed. Oh, I know what it's going to... Oh, I'm an idiot. I am so... Oh, my gosh. I know what it is. Okay, here we go. 2 seconds. Let me go here. Okay. I think I know what the issue is. Because... Okay, let me try this. I should have realized that. Okay. Okay, that gives another different row. So that gives another row. And that gives another one. So you guys are getting 15683, and so you both confirm. Oh wait, I get 96. Okay, wait. So you get 9628. That's the one I got just a moment ago. They're not. There it is, 9628. Okay, so I understand why people are getting 9628. There's different ways that random numbers are generated, and this is controlling. It's like playing on like Xbox or PlayStation. So you can choose to do a different type of randomness. And so I think people are using rejection. I think that's what their thing is set to. And let's check. Okay, so it's rejection. So when I run this now, I should get the same results. And I have this trainer right here. There we go. Is that the ROC you're getting? Let me see if I remember your ROC. No, you're getting 0.65955. And let me check my train row again. It's that one. Are you using the data train right here? Double check everything. You just ran and got 12. Nice. Okay, wait. I think I just got the same thing. Okay, Jake, you got this. You got the same thing right here. This is the result using rejection. And then I think you might be using rounding right now, because if you're running and getting this one right here with 12.9. Oh wait, did I show it? Oh my gosh. Is that the one? I just ran it again and got... Double check. You might be regenerating the data. I can double check with people, but what you want to do is you want to run all the code in order. So let's say we go ahead and take... I think people are using rejection. Let me confirm. So let's all use rejection right here. Let's all use rejection. So we're going to run just this whole chunk as is, just to see if everything works. There's the ROC that Jake is getting. Is that the one that's in the file? It's very, very close. I mean, I don't know why. They might have updated the way it works. So we need to check these sanity checks. The insanity checks. So what we're going to do is we're going to take this rejection right here so we can all have the same answer. We're going to put it right here at the start of this to control the randomness. Exactly. And so yours, yeah, it's just make sure there's ways that it's so insanely close to it. It's so insanely close to it. Let me check something real quick. Let me check. Make sure the key is working. 2 seconds, because that's a good way to do it. Let me look at the key. Because the way randomness is created can control stuff. Okay, let's go grab the key. Let's grab the key right here. The key, all the answers. And let's see if everything is in line with the answers. Okay, I'll be showing in 2 seconds right here. Okay, let's go right here. According to the one, but it's asking about the according to which of the two models are better. Experiment grid. Just checking a few things right here. Here we are. Okay. Okay, let's check. Okay. Let's take a look. What's overall right now? Just running everything through in my mind. Calzone right there. How you doing, Calzone? We have a new status, Calzone. You're probably at the new tier. We made a new tier up for class. So here we go right here. 0.62452. And is that what the very bottom of the document says? 0.6. See, I'm pretty sure. Do we still have that in our copy paste? Because here's the logistic regression results. Yeah, it's an error right there. That is an error in the file because this is the key right here. So the answer, and what was, Jake was saying, this is when I was like, I know I look over everything we do, and it's just an error right here in this number. That should be this. And this should be that. So, and then, and then we should solve it mathematically. Yeah, wait, is it exactly equal to 1? No way. No way. That's ridiculous if it is. Is my brain just not working? Let me try changing this number. Whoa. So it's iffy. It's hard to say. They're exactly 1, and that is so weird. Let me look at the R part. Let me look at the best fit on the R part. Yeah, make it rejection. Rejection was working and getting... Yeah, that's the one for that. Okay, so that's working. It's weird. Yep, and it's exactly 1, which is so weird. Let me look at the 2 ROCs. ROC standard deviations. That's this one. So, wait, is that not the bigger one? No, it's the smaller one. Wait a minute here. Why is... This number here is wrong. I don't know why that number is right there. That number is wrong. I would replace this whole thing. I need to re-upload the file. Because this right here... Can I run that code like that? Yeah. That is way greater than 1. There we go. How do you know which model to pick? Using the 1 standard deviation rule right here, we see how the model's performances and see if they're more than 1 standard deviation apart. This response should definitely be removed. As we speak right now, I'm going to go and remove it. Class is not over, Calzone. Don't leave, Calzone. I'm going to go remove this response because it's definitely going to cause some confusion. I might even send an announcement that the response that was there was not a valid response. I don't know why that response is there, but that response is definitely causing confusion. Calling calling this update and editing the file. Sorry about that. I think as the semester gets closer to an end, we're all just like, oh, it's just so much. Let's see right here. Okay, so I have updated the file, and it's due tomorrow. But we'll probably be grading that really lightly. Yeah, I know. I think all of our brains are just fried completely. So I've uploaded the new file. And also everyone here kind of got the inside scoop on it. And I'll have to kind of make sure we know this, that there does look to be a big difference between the models. Unless I'm just going mad, right? Unless I'm going mad because we've got the GLM. Tell me, everyone, if I'm going mad right here. We're looking at the ROC right here and the ROC standard deviation. So the formula for this is going to be, if we were to take the ROC right here, let's go here, ROC1 is this. Here's ROC1, and here is ROC2. So here is the formula for it, ROC1, ROC2. Then what do we need to compare ROCs? What do we need to compare ROCs? To compare ROCs, we need what? To compare ROCs, we need the what's for them. It's a 201 topic right here. Don't worry. I'm the 201 person says it. I'm like, yeah, you get the advanced topic. So to compare things, we need to take the differences and what them. So we're going to turn them into a what. To compare things, we need to take the differences and blank them. And to do that, we'll divide by the blank, which will turn them into blanks. So because, like, what if I tell you I have one more than you? You'd be like, well, one more what? I'd be like, one more penny. You'd be like, who cares? Like, one more yacht. You'd be like, wow, that's a big difference. So to compare differences between ROCs, we need to do what to the differences? To compare differences in these ROCs, we need to do what to the differences? What do we do to the differences in ROCs here? We can subtract them and we can find a difference, but what could we do to compare the differences? No ideas? Oh no! Listen to my new song. Standardized Z-scores. Alyssa, you're right. Right as the inspirational music hits. 2 times. We'll see if YouTube takes down this video. If this video has ads, it's my fault because of amazing music by Josiah Wilkinson. So we'll find out. Monster Cat hit us with a copyright. There we go. So what do we do here? We go ROC1. How does YouTube? It's like content ID. It listens, and so it can tell. But go look up Josiah Wilkinson. Amazing channel, Josiah Wilkinson. I'll put him in the chat right here. Go YouTube him. Amazing pianist on YouTube. So I want to give him shout outs as I use his cover of Coldplay right there. Shout outs to Josiah. And so we're going to divide by the max of the numbers right here. I think we have to concatenate inside of here. So ROC, and there we go. That's got it. So is this difference big or small? So this is a Z-score of 5, Dan. Is that a big difference? And it's kind of like you're comparing means because you're just taking the difference between 2 things and standardizing it. This is very, very nearly identical to the formulas we've been doing for 201, where in 201 we take, just look at this, we take y bar 1 minus y bar 2 over the standard error of y bar 1 minus y bar 2, which is the complicated square root of all this stuff. So we'll definitely do some chapter. Yeah, it's definitely, and it's, you have to be transformative. So by playing his music while I'm talking over it, it's so transformative. And I've gotten hit with copyrights on videos that are like 2-3 years old, where I think things change hands. I think ownership of certain things change hands, and someone's like, "Oh, we're gonna copyright claim his video now," and it's like, what are you gonna do? So do you notice right here we have the ROC1 minus ROC2 that's virtually identical to this, and then we have right here the max of the standard deviation that's virtually identical to this. This one solves out to a t-score, but this is why, you know, learning stuff in 201 really helps for upper level classes because we're doing the same thing right here. We're just taking a difference between two things and we're standardizing that difference. And this is actually a z-score over here. So this is how many standard deviations these two things are away. That's got it. Let's do some 201. Dan, which one? You said confidence interval questions. You're welcome, Alyssa. Great questions right there. I think Dan wanted some confidence interval questions for chapter 17 and chapter 19. Chapter 17 and chapter 19. Oh my gosh. Yeah, we got to talk to the graders about grading. Say, hey, graders. Let me contact them after this. So, because I'm looking at what needs to be graded, and I'm like, okay. They are a little bit behind right now. Let's go ahead right here. Go to Vital Bookshelf. And let's take a look. So which problems were you working on, Dan? Chapter 17, I just need a run through of all things. Let's talk about chapter 17 homework first. Let's go to chapter 17 homework. Okay. Let's go to chapter 17 homework. And then 320 had some questions too. I think Ahood was wondering about just in general. We can do some review in general here. Okay, this one's really great. It kind of coincides with the interval we were doing last night. I know, Dan, thank you so much for the comments on the videos. That just helps the algorithm. So if anyone's watching right now, leaving comments on the videos, if you want to do that, that helps the algorithm. It sounds out. And we get views from other universities. We get views from like, maybe Taco is from another university, but I've been contacted by students at other universities. I've been contacted by instructors saying they use our videos. So I really like that. And a lot of these videos are no ads and stuff like that, especially if it's a straight education video, I don't put ads on it. If it's something more that takes a while to create, I'll usually put an ad so we can do cahoots and make money and like give out money, make money to give out money. That's what we do. So what do you notice right here about this interval, Dan? This interval is completely what? This interval right here is completely what? That interval right there on the side of the screen is completely what? That interval right there is completely negative. You're exactly right. And with that interval being completely negative, what does that mean with that interval being completely negative? We're going to make this a tiny bit smaller. With that interval being completely negative, I want us to think about mathematically what's going on right here. I'm going to try to put this on the screen with me. That should work. That should work. Okay, let's erase what's on here. And let's talk about this. We have two hot dogs right here. And we're trying to figure out the difference in their fat content. And we have beef minus meat, whatever that means. If this interval was that the mean for beef was something like 10 and the mean for meat was 6, this interval would have a positive number right here. But since the interval is negative, think about it. If it's negative, that means it's more like this right here. So since the interval is negative, it would have to solve out like this. So basically the trick is if the numbers here are negative, then the second one was higher. On average, like we think that the mean for meat would be higher because the numbers here are negative, telling us that there's a negative difference, which would only come from the second number being higher. But if the difference were to be positive, which I think I can go back in time and get to that. Can I? I can't. Went too far back in time. If it were to be positive, something like this, it can just be any sort of numbers. Then what does that indicate? It indicates that there's evidence the first mean is higher. Now, especially when we look at this, there's an issue with the interval though. When we look at the interval right here, if we have an interval trying to estimate the difference between these two means, which we can use the subscript on them, if we have an interval trying to estimate the difference between the two means, and there it is right there, what if the interval goes from like -10 to 1? So it might be, and this will relate to last night's question, it might be that meat has this much more fat in it. What would be the answer to that? It might be that, we're 95% confident that the true difference between beef and meat hot dogs is contained in the interval -10 to 1, but it might be the case that meat has how much more fat in it. Because remember what we just did. It might be the case that meat has how much more fat in it. So how would you be able to estimate? It might be the case that meat has this much more fat in it. What would be that? It might be the case that meat might have up to this much more fat in it. And this helps with the visualization assignment. It might be the case that meat has up to this much more fat in it. 10. Because this one corresponds. Oh no, why'd you do that? It had to do that, didn't it? This one right here corresponds to the negative one. It might be the case that meat has up to 10 grams more fat in it, or it could be the case that beef has 1 more gram fat in it. Like the difference between beef and meat hot dogs and the fat they have, it could be that we're 95% confident that this difference is contained in the interval, that meat could have up to 10 grams more fat in it than beef, or beef could have 1 more gram fat than meat. Does that make sense right here? Because the positive number corresponds to the first one possibly having more, and the negative number corresponds to the second one possibly having more. If the interval is completely negative, then we think there's a difference, or if it's completely positive. What is in this interval right now, Dan? Like, what number is somewhere in this interval inside of here? Well, that kind of gives a hint. What number is in this interval somewhere, which maybe makes us think there's not a difference? Because we're saying it could be that meat has up to 10 grams more fat, or beef might have up to 10 grams more fat. So what number is in this interval somewhere that means maybe there's not a difference between these? What number is in this interval that is like, well, maybe the difference is equal to 0. Maybe the difference is equal to 0. Exactly, Dan. Nice work right there. Maybe the difference is equal to 0. Maybe there is no real difference between these. And with this, we would, fail to reject the null. We would not have evidence. So it's probably right here that meat is higher because the interval is negative. So this is higher for meat. Is that the meat one? My eyes are deceiving me. Yeah, it takes a little. It's practice. What does the fact that 0 is not contained in this interval mean? Is this going to be, what answer do you think, Dan? A, B, C, or D? Since 0 is not contained in this interval, what does that say about the difference between the two? So we don't think 0 is a possible value for the difference between this hot dog's fat content. We don't think 0 is a possible value. So which of these would it be? We don't think 0. It's significant, exactly. So, and that's kind of what we were reviewing right there. So since 0 is not in the interval, we think it's significant. And this was done with 91% confidence. So if we remember how to do our confidence intervals, I gotta delete some of these Word documents. So if we remember how you got it, Dan. Dan already knows. Great job right there, Dan. And we'll draw our quick picture right here to remind everybody who's watching. When you make a confidence interval, if you make a 91% confidence interval, so 91% corresponds with a two-tailed alpha of 9%. So the alpha right here on this test, the total alpha would be equal to 9%. So 91% confident, 9% on the outside for the two-tailed test. I wish it said two-tailed on there. It should. So there we go with that one. This one wants us to do the margin of error. The last part is difficult. The wording, yeah, I know, right? It's hard. Like, what does it correspond to? Let's close out a document or two, and I'm going to use the same document. Should have shut down the computer last night. Then I wouldn't have this issue. Okay. So with this one right here, the margin of error. How do we do the margin of error? The margin of error, there's a lot of ways to calculate the margin of error. The margin of error for this problem, the long way, is going to be T star with degrees of freedom square root S1 squared over N2 plus S2 squared over N2. But we're not going to do that right here. We're not going to do that. The margin of error, when we think about it, is the following. It's half the length of the interval. Here's the whole interval. Here's half the length, the plus or minus. So when you look at an interval right here, just keep repeating yourself. The margin of error is half the length of the interval. So this is a margin of error right here. This is a margin of error right here. This is the center of the interval. This is the lower of the interval, and this is the upper of the interval. So if we go upper minus lower to get their distance, that'll give us this right here. And then we're simply going to take half the distance of the interval, and that is equal to the margin of error. Now, there are other formulas like center minus lower or upper minus center. Those can get you the margin of error, but probably my favorite and easiest one right here is half the length of the interval. Awesome, Rocky Top. Yes, which one was it over? What was it? If it's something I can cover here, I can do it. If it's something, tell me, we'll go over it. Upper minus lower divided by 2. There we go. Type an integer or decimal round to 3 decimals. Knowledge homework. Oh, super exciting research. Oh, that's awesome. Congratulations. I'm really excited. Yeah, let's check that out. I think I just heard it bling literally in the background. So the margin of error, if we went to a 90%. So remember this. So when you're at 99 and you go to 90, what would you do? Would you go in or out? So need a fancy stats person? Definitely. So this one right here, the error would be what? The margin of error would be what? If we go from 99 to 90, what would happen to it, Dan? It's going to be water smaller because the critical value, and that is going to actually be what we were showing just a second ago right here. The critical value, did I still have it? I think I can bring it back. I think I can bring it back. This T statistic right. No, I deleted it and it doesn't undelete the delete. The T statistic is this T star right here with the degrees of freedom. This is what's going to get bigger. This controls the confidence level. And I can do this the easy way. This is the standard error of the difference of y bar 1 minus y bar 2, which I wrote out just a moment ago. Rewind. So because the critical value is going to get, oh, it's going to decrease, right, Dan? You're right. Because this, sorry, for my brain just didn't work right there because we're going from 99 to 90. So I think I might have misspoke. We're going to go from 99 to 90, and the bigger the T, the bigger the confidence is. So the T directly relates to the confidence. It's going to decrease as the level of confidence decrease, and the margin of error decreases as the critical value decreases. That's a lot of decrease, decrease, decrease. That's a weird question. I don't like it. No, sir, I don't like it. Explain what the created interval means. I am 99% confident the true difference between traditional test scores and non-traditional test scores, or non-traditional and traditional test scores, is contained in the interval 6.254 to 12.146. And you know what's really great about this? The variable TDF, is there an easier way to solve that? I'll show it here in a second, Dan. Really good question on that, the T with the degrees of freedom. For this question right here, if you look at the way this is, you could use this in your project or your visualization. So if you're watching this right now, this right here with 99% confidence, a student in traditional math is expected. No. We want the non-traditional, because remember the difference here is positive, which means the first mean is higher because we have a positive difference. So a student in non-traditional math course is expected to score between this many points higher to this many points higher on a standardized test than a non-traditional. That looks correct. This looks correct. With 99% confidence, student in non-traditional math classes are expected to score between this points higher on the standardized test scores. Then, so what's the difference right here? Oh, I see it. Okay, there's a small error I almost made. I almost made an error. What is the difference between this and what is the difference between this? Because they both talk about the non-traditional scoring higher. Does anyone see the difference? And I almost got caught by it. Not today, my Pearson. Not today. We've been on a streak lately. I don't think we got one wrong for like a class or two now. We haven't got a single part wrong. Singular versus plural. And we're analyzing the mean right here. So if we're analyzing the mean, should it be B or C? We're analyzing the difference between the means of these groups. Oh no, my head's covering up the words. Let me fix that. We're analyzing the difference in the means. We're analyzing the difference in the means. So we're analyzing the difference in the means of these groups. So since we're analyzing the difference in the means, what are we going to use? Would it be B or C since we're analyzing the difference in the means? If we're analyzing the difference in the means, it'll be C. Because, oh my gosh, this question just keeps going down lower. It's just, there we go. Does the result suggest that students who learn in, can I make it really big and then it'll work? Let's try this. I'm almost out of its way. Because do the results suggest that students who learn in mathematics with non-traditional methods will have significantly higher scores on traditional? So the answer is going to be yes. You're welcome, Rocky Top. The answer is going to be yes right here. But I don't like the wording of it. It should say, does this give us evidence that students who learn in the non-traditional setting will score higher? Does it give evidence that this is a better method? And the answer is yes, it is good evidence. I guess suggest is the idea of evidence. I can't complain too much. And it's because 0 is not in the interval. The entire interval is above 0. There is strong evidence. And this means we reject the null. We have evidence for the alternative. So we're going to reject the null and have evidence for the alternative. I almost broke the streak. Here are how to do a lot of the problems we're about to show right here. And I think I could code this, but so this problem right here we did yesterday. It's in yesterday's video and it's time-stamped. It's time-stamped a man on 2 routes. We might skip this one for now. Is it the serial one next? Is it serial? We might skip the serial one. We might try to do all the questions in chapter 17, but these both are in yesterday's video. We might loop back and do them here. Dan's here. Dan gets priority, or anyone 201 or anyone that have any questions gets priority. If you're like, hey, do that one. I want to see how it's done. But we're going to do other chapter 17. So if you're looking for these ones you just saw and you're like, oh no, I need these ones, Brian, do them. I can't get in the first link. Oh, I think there was an issue with it actually. I had an issue with it yesterday too when I was looking at the slides. I don't know if I need to tell Charlie this and we need to actually update it then maybe. There you go right there. That should work. And this kind of relates to your question, Dan. Let me bring this over here. And then 2 seconds. Stat distributions. T. Here we go. And so this is the other T distribution I like here, Dan. So I like this. Wait, what? For some reason, the first link isn't working. I don't know why. This one right here. But tell me if you have any issues or tell me which one you want me to do. I'm going to bring up the quiz and let's take a look at some of the quiz questions we haven't done yet. So we're going to do a quiz question we haven't done yet because these are pretty tricky. They take a lot of practice, just understanding the notation. We need to do notation quizzes. I think of new things to do I don't know. It really is if you don't use it, you lose it. If you don't practice it. And we did that one. So we've done that one. I'm going to try to do as many as we can, get a video on every question. So people have help for everything they need. Oh, you thought we did the margin of error one. So we've already done that one. We did the moving one yesterday. We did the serial one. So we should start to see new ones now. Here we go. Here we go. Okay. Researchers collected water samples. I got to go one size bigger. Researchers collected water samples from streams in a mountain range to investigate the effects of acid rain. They measured the pH acidity of the water and classified the streams with respect to the kind of substrate, type of rock over which they flow. Lower pH means the water is more acidic. The plot to the right shows the pH of the streams by substrate, limestone, mixed, or shale. Selected parts of the software analysis comparing pH of streams with limestone and shale substrates are shown below. Complete parts A through C. Okay, so we're going to test the difference between two means. It gives the t statistic, and it gives the p-value, and it gives the degrees of freedom. Well, that's cool. So what are we testing right here? Which means state the null and alternative hypothesis for the test. Well, so we're only going to be testing two means. This one's easy. How do you identify the answer right here? It looks like there's a lot, but it's pretty easy to identify the answer. Take a drink of water. What is the easiest way to know the answer on this one? Who would love this as a test question? I would love this as a test question because there's a trick I tell you all the time that makes this one super easy to identify which is the right answer. You might say, gosh, I guess there's so much on the screen right there. We're doing limestone versus shale. So it's the difference between limestone versus shale. And then there's an easy way to know the answer each time on this one. Like there's an instantaneous way that I'm like, that's the answer. The null has the what? The null has the what? And that gives away the answer. The null has the what? This is a pretty good test question then, right? Yep. There you go. The null has the equal sign. Oh, we got to do the rest of it. The null has the equal sign. The conditions are... Oh, no worries. The conditions are condition 1, randomness. I usually yell it, but I don't want my neighbors to get mad at me. Condition 1, randomness. Condition 2, 10%. Condition 3, nearly normal. And condition 4 is independent groups. I'm going to assume that these groups are independent of each other. Independence is randomness and nearly normal. And it doesn't list 10%. I wish it did. It is a condition. They should list it. As far as we know, those conditions are met. Independent groups means that the limestone and the shale groups will not impact each other. What conclusion do you draw? You know what? I'd really like to talk to my Pearson about this because they say the difference is... What was their sample size? They're saying the T statistic is this. And with degrees of freedom 48, that's a... I want to know if they used real data on this because I don't think they did. The more I look at this question, the difference right here between the two groups, and you notice here's where the median is at. Now it's going to be skewed to the right, left to the low. It's going to be skewed to the left even. I get tricked sometimes. It's going to be skewed to the left a little bit. And this one, I guess, is skewed a little bit up. But there should be a good amount of observations from the degrees of freedom. And so overall, we are going to fail to reject the null because of the p-value. So there is not evidence. So you only have one option, or you can only fail to reject. There is not evidence for the alternative, or you can reject. There is evidence for the alternative. So we are going to fail to reject. There is not evidence for the alternative because of the high p-value. And I would just like to know if this came from real data, because this difference right here with the sample size and everything looks like it should have a t that's much higher and a p-value that's much lower. It's just a qualm with the question right here. But do you understand what this is showing right here? Do you understand what this difference between the means is? Like if we could view the means between the yellow and the red group, we'd see a difference of 0.735. That is the difference between the means. These are medians, and the median for this group is somewhere on top of one of the quartiles for the yellow group. The t statistic is coming from the formula. What is the p? What is if the p-value is 0.0001, reject the null. What if? Yep. That would be a very, very small p-value. Anytime the p-value is lower than alpha, we reject the null. So when the p-value is lower than alpha, we reject the null. When the p-value is low, reject the null. When the p-value is high, just let it fly. So good questions, Dan. Keep them coming. Keep them coming. Here we go. This question is a little bit more difficult. It's the bold question right here or the glass question on how much people are going to put in a glass. Don't be tricked. I think sometimes they put more in the smaller glass. And subject equals donuts. That's awesome. Love it. Everyone knows I love donuts. You know what? Could Chelsea and I get donuts? The world needs to stop being on fire. Just popping in to say, oh, you're welcome, Nikki. You're welcome. We're doing chapter 17 right now. So definitely check this out later. We're getting as much as we did chapter 17 some yesterday, and we're doing the rest of it today. We're going to get all the work done. Everyone's learning, going to make some great grades. Everyone, we're excited about donuts. Okay, so what do we have right here? Researchers investigate how the size of a drinking class affects how much soda people tend to pour in themselves. People were randomly given, random right there. Hey, Brian, have you worked most of the problems? Which one are you working on, Morgan? We can go back and work one. You're here, you're asking questions. We can go back and work another one. I'll finish this one. Whichever one you're working on, we'll go and work on that next. And we're just practicing some chapter 17 right now. Differences between two means. So let's do this right here. They want to know if there's a difference between the two groups. Did the glass size change the proportion size? So what does the null have? The null always has the what sign? Really easy right here for this one. Is that what you'd like, Dan? Would you like me to go back to the homework? Because there's two more questions on the homework. We could go back. The null always has the what sign. The null always has, we just know it's instantaneously. It's like the null has the what sign. Yeah, we'll do that one next. We'll do sugar content. You got it. And then what does this suggest right here? They're asking, does it change? So they're asking, is there a change based on the size of drink they have? So what would we have here if they're asking, does it change the size? Does it change? Not equal, exactly. And that's the key wording right here, does it change? So you always have to look to the question itself, not the data. Don't be like, oh, the bigger glass has more. So we're going to say here that the mean for glass 1, I think, is glass 1 mu1. Does it not even tell us which one's mu1? Well, that would make it really hard. Unless I'm just... Yeah, okay, small glass. So it would actually be less than if we were to do it that way, but we're not. So we're going to say that they are the same and different. That's got that. So this kind of relates to the first question now, but it gives you all the notation. So what we're going to do is we're going to take the notation. We're going to copy the notation. And we're going to bring the notation over to our Word document. We're going to expand the Word document. And we're going to delete. And we're going to put it in right here. And this is very much like the bike problem. We'll do the sugar problem next right here. The sugar problem, so stay tuned, Morgan. We're going to do the sugar problem next. It'll make life a lot easier, hopefully. Good, and let's do this. So the t statistic with degrees of freedom, which we do not calculate by hand, is equal to, you're welcome, Morgan, great job. Y bar 1 minus Y bar 2, and this is 1, 1, 1, 2, 2, 2. And we go right here, put our line a little bit better. There's a thing in Texas called Torchy's Tacos, and I really want it. If you're a Texan or somehow you had Torchy's Tacos, I don't know if they're all across the U.S. They're definitely not in Knoxville. They're no soccer taco, but Torchy's Tacos. So let's go ahead and start plugging in the numbers right here. We've just seen the formula. And this is going to give us the t statistic with degrees of freedom that we will calculate in a moment. And so we need the first mean, second mean, and standard deviation 1 squared, and standard deviation 2 squared, sample size 1, sample size 2. There we go. And let's do this right here. 1.87 divided by this. We're going to copy that. 2.78 times this, divide by that. Add them together, square root it, and copy this. 5.32 minus 6.26. Divide by that, and there it is right there. So negative 1.45. There we go. That's got the t statistic. As long as we did it right, we'll cross our fingers. Now this is the tough part. So the t statistic right here we got, but now the p-value is the really tough part. And I'm going to put the link in the chat again. The link we need right here is going to be to get the degrees of freedom for this test, and we need to use the following information. We need to use the sample sizes and the standard deviations, 26, 1.87. And then we need to use the next one, 27, 2.78. There we go. Oh, 27. I think this was 1.87. Let's double check. Oh my gosh, I can't type. Let's double check the numbers. 1.87, 2.78. And we've done it. 45.684. And now we go over to the applet here, plug in the degrees of freedom, plug in the t statistic, and don't forget that it's two-sided. And there we go. The p-value is 0.157. There is the p-value for the two-sided. We're not doing a less than test. We're doing a two-sided. We're not doing a greater than test. We are doing a two-sided test. 0.157. And I'll put this applet in the chat right here. There's the applet I'm using right there in the chat. So let's go right here and put in, 4 decimals. 4 decimals. Oh, no, why you do that? Let's go get the 4 decimal answer. To get the 4 decimal answer, we need to go to another applet. So here's the applet I like to use for 4 decimals. Let me put in the answers real quick. So the degrees of freedom were, I'll show it here in 2 seconds. There's the degrees of freedom. It probably would give it to us. And there's the t statistic. And here's the two-sided. I wonder if it would give it to us. So this right here is the applet I use to get the extreme decimal accuracy, if you ever ask for that. But I think this is like one of the only questions that I probably would give it to us, because this is 0.154, and there's probably enough leeway. Ooh, that is different. Oh, it might be carrying it. Let me see if it answers that. I'm going to put... So this is the answer I'm getting right here. Let me copy that. Let's see if it has enough leeway. So we are going to do not reject the null. The data does not provide that there is a difference right here. Alpha 0.05. Is it not liking the p-value, really? Yeah, it's really... How much leeway is there on it? Wow, it really wants an exact p-value. Yeah, it's asking down to the decimal. Let me look at the other one too. That is crazy. You only get like 3/1000ths leeway on this one. I'm still not getting the correct answer on the BAS 474. I just rewatched the whole portion that you went over. That section, could I send you my code? Yeah, send me your code, definitely. Are quiz questions sometimes the same as the homework? Definitely, yep. Quiz questions are sometimes the same as the homework, so we'll go back and look at the homework. And let me look at the applet we link to normally. It's just, It's not one of my favorites because it's not as visual. I'm going to go to the applet we send people to. It's on the Stat1 resource site. Let me go to distributions. Oh, wrong button. Distributions T and chi-squared. Okay, here we go. And this one right here is pretty basic, but it gets the job done. And let's look at it real quick. Okay, so our T value, let's go, sure. Here's our T statistic calculated to extreme decimal accuracy. And here is the, here are the degrees of freedom. And degrees of freedom there, and probability. Oh, we need to go to two-tailed test. I don't like it's not visual. And there's the answer right there. So I think that's the answer we put in, 0.1541. And then with my applet that gives extreme answers, we got the same. So 0.15, yeah, and then 41, it worked when we did that. So it is working out fine. I hate it when it asks for 4 decimals. It's, yeah. I think so. Let's go back and let's do the sugar content one. That's the one we're going to do right here, the sugar content. So sugar content's going to be right here. And let's take a look. Now this problem right here is basically practicing how to read jump output. So we're going to practice reading jump output with this question. So get ready. We're going to go right here and go to copy to clipboard. We're going to copy the data. Data is now copied. We're going to go into jump right here and go to a new data table. A new data table. Now in this new data table, it's very important that you go to edit, paste with column names. Make sure to paste with column names and you'll see the column name appear here in the top. If you don't paste with column names, it'll look like this. If this happens, restart. Do not try to fix it. There is a way. It's way too complicated. It's just easier to open a new data sheet and paste with column names. Make sure to do the way I did, going to edit, paste with column names, and sometimes I use the quick shortcut Control-Shift-V. So now that we have it pasted with column names, you should see blue. If you see red, there's an error. Blue means quantitative. Let's go here to tables and then go to stack. I'll pause right here. So if people are watching live, they can do this. Go to tables and then stack. With tables and then stack, we're going to double click both of these and then we're going to click OK. So now we're going to stack these on top of each other. With these stacked right here, we're just going to expand the window. And now we're just going to make some nicety changes. We're going to call this type of cereal, and then we're going to call this sugar. You don't have to change this. It's just nice. And I just double clicked them and changed them. You don't have to do it. So we're going to go here to analyze and then fit y by x. And this is what you're doing in your visualization assignment. If you notice, we have a categorical 2 level type of cereal, children's versus adult, and we have sugar, which is a quantitative y. So this will be a 2 sample t-test or 2 sample t-interval, 2 levels of cereal type, and sugar is quantitative. So let's go ahead and click OK, and then let's go here to the red arrow and go to t-test. Now this also does a t-interval for us. And if you're doing the project, you can also take a look at the quantiles, and this is the output you would need for your visualization assignment. So make sure to have all of this. So if you're watching this right now, make sure to have all of this, including the box plots, the quantiles, and the test down here below. You can change the level of confidence by going to set alpha. We don't need to do this for this problem, but this changes the confidence level here for the interval. So you can do that for the project. It's in the video for the visualization. So if you notice right here, we get the interval, and that's the answer to the question. I am 95% confident the true difference between adult cereals and children's cereals is contained in the interval 31.5 to 40.09, where children's cereal is more likely to have sugar, the higher amount of sugar. 31.5. Let's go back here. So 2 decimals, 31.50 and 40.09. Was that correct? We're 95% confidence. Exactly more. And I think it was 31.50. Let's see if I put them in my head correctly. Did I? I did. Does this make sense right here, Morgan? That we're just basically doing jump output and knowing how to read the jump output, and that this is the difference we see between children's cereals and adult cereals. And since the difference is positive, we see that children's cereal has in it usually more sugar than adult cereals. We're 95% confident the true difference between children's cereal contents of sugar and adult cereal's contents of sugar is contained in the interval 31.5 to 40.09, where it looks like adult cereal has more sugar in it on average. I mean, children's cereal. Oh my gosh. Oh, the column thing? Is it red or is it blue? What's the issue? We don't have any questions right now, so we can fix this up. Is the stack did not work, did it? So here, let's go from the very beginning. You ready? At the very start of this, you want to go to a new data table. So we just need to open up a new worksheet. We're going to go to File, New Data Table. Make sure you're using a new worksheet because you have to use a new one or sometimes it'll carry over. Awesome, Mackenzie. Awesome, Mackenzie. I'll take a look after class right here. We'll try to get it working. I am almost out of water. I drink like 4 glasses of water a day, which has probably helped a lot. So new data table. In the new data table, go to Edit. Yeah, which topic do you want me to go over, Hood? We could do some 320 right now. Which topic do you want me to go over more in depth? Which topic would be, like, which topic are you thinking about? Or do you have a question on the assignment? So we're going to paste with columns. Then we're going to go to tables. And we're going to go to stack and make sure it's blue. If it's not blue right here, alert me, tell me it's not blue, and we can fix it. We're going to go here to stack, double click, click OK. Here's our new data sheet. We don't actually need to change it. We can just go here to analyze, fit Y by X, put the X here, put the Y here. Awesome. Maybe we'll do some of the true false stuff here in a second. We'll do that really quick. And that's got the results. Let's take a look at just some random. Let's go to the end and look at random ones. Well, these are bigger questions. Let's see here. What would it be? Choose the correct answer. Or was it, suppose an experiment was done together, the number of unpopped kernels in the microwave. Half of the students in the class took the bag, put it in the freezer overnight, and popped it the next day. The other half left it on the kitchen counter and popped it. Each group counted the number of unpopped kernels. Which of the following is the appropriate alternative hypothesis? And it should be that they're not equal. This right here uses the means. And oh, wait, what? Oh, wait. To test whether the freezer method left fewer. Oh, no. Wow, that's our first one wrong. It went way too quick. I should have used the process of elimination when you have 2 similar answers that you have to pick between those. I should have done that. I thought that we were just checking to see if a difference was found, but we're seeing if the freezer method left fewer uncooked kernels, and so that's that right there. Does it always say that? Well, that's always the answer to that one. It tricked me. It tricked me. So suppose an experiment was done to gather the number of uncooked pop kernels. Half the students took the class bag home, went to the freezer overnight. The other class took it, left it on the kitchen counter, and popped it. Each group counted the number of uncooked popcorn. Could the methods for this chapter be used to compare the means? Yes, because they're independent of each other. And that's it. That's an easy one. And here are June and August comparisons. Oh, and we can't do it, I think, right here. So having done poorly on finals in June, 6 students repeated the course in the summer, then took an exam in August. If we correspond these students representative of all students who might attend the school in the summer, explain why you can't use the methods discussed in this chapter for this test. And this is because they are dependent, because the student right here is retaking the course in August. That they're taking it, are these 2 summer courses? So they're taking it in August and they're repeating the course. So these are dependent. And since these are before and after scores from individuals, not independent samples, this violates the independent groups right here. There we go. There's got that. They are not independent. And we've done a lot of these now. I've done a lot of these. We have most of them done. And the other ones are either jump ones or notation ones. Can you go over assignment 9, Q2E? Yeah, of course. Let's do it. Let me pull up assignment 9, Q2E. Let's do that. I really, I don't know. Maybe I should make some tea today. You know what? I might do that. I might make tea. I might make some tea. I keep saying that to convince myself to make tea. So this is assignment 9. And for some reason, my jump doesn't have a label and data to put into the Y and the X. Can you send me a screenshot of it, Morgan? Can you, and I'll take a look here during office hours. Send me a screenshot of what you're seeing. Use either Command-Shift-4 on the Mac or snipping tool on the PC. And send me a screenshot of what you're seeing. And send me the screenshot, and I'll take a look. 2E. I tell you, once Thanksgiving hits, we're to make a really good turkey and everything. Just, I'm gonna get some ham, some turkey. I'm just gonna go crazy. So first Thanksgiving with my fiance, really exciting. So now fit a model predicting demand using all predictors. So let's see right here. We're predicting demand for the bikes. I am Oh, wait, so okay, did you get it figured out? Don't worry. Oh, it cracks me up. Not this one. Wait, is it assignment 10? Or assignment 10 or assignment 9, Ahood? Because assignment 10 is the one out right now. Did you mean assignment 10? Let me see right here. Let me go back and get assignment 10. Assignment 10. Logistic regression. I'm assuming assignment 10 then. 2E. 2E. 2. There's no 2E, is there? Oh. Which one is it? The last part of assignment 9? Oh, are you talking about these right here? Or are you talking about this right here? Okay. This one right here, Ahood? Is it this one? Among all 6 types of products, bed small, bed large, kitchen small, kitchen large, awesome. Which one has the highest average sales among them on average? So when we look at this, let's go ahead and get our equation written. So let's go ahead and do, so this is going to be sales equals, and let's take and start writing our equation. So remember what we do right here, we just take, and you know what I'm going to do? I'm just going to take all of these to start, and I'm going to put in I'm just taking all the coefficients first, just because it's easier. I don't know why. Then we'll put in all no. There we go. And now let's go here, put that there, put this here, go smaller, take this, put this here, and put this here, and we did it. Oh, you're welcome, Morgan. Great job, Morgan. And does this make sense what I did right here, Ahood? That we now have the equation with the indicators in it. Maybe we can go one font bigger. Whoops. We now have the full equation with the indicators in it. Good. So as long as we can get this step right here, and we can get the equation with the indicators. So which room has the highest amount? Kitchen, office, or bed? For products sold in a room, which room has the highest amount? Kitchen, office, or bed? Which room would have the highest amount? Kitchen, office, or bed? So if we look at the coefficients of kitchen and office, they are negative. So which room will have the highest? Bed, you're right. And so the equation for bed is going to remove these. So because we're going to put in zeros. So if anyone's wondering why am I saying remove them, it's because this right here will become a 0. And so that becomes a 0 when we go and say it's in the bedroom. And this becomes a 0 right here. And then these are removed from the equation just mathematically. Now, which would be higher, small or large? Which would be higher, small or large? Which one of these would have a higher regression model, small or large? Which one of these would have a higher, small or large? Large, exactly. Oh, no, not large. Yeah, oh my gosh, my brain is... No, small. Should be small, right? It's small. Sorry, I thought I got it wrong. And then, see, even my mind's just like, wait, which one? So why is it that small will have a higher sales? Why will small have a higher sales? Because the coefficient is positive for small. Does that make sense, Ahood? The coefficient is positive because if we put that this is a small product, what does that mean we'll plug in right here? We'll plug in a 1, and then we can mathematically solve for this, and then we change the regression equation to the following. And here is the new regression equation. So this is the new regression equation right here, and I guess we could be nice and maybe do something like that. But this is the regression equation for large, small items in the bedroom. So, so wait, is that not 2? Sure, there we go. So this is small bedroom items right here. But what if we had another spot? We had something like garage. And garage had a very easy coefficient. Garage's coefficient was just positive 1. So the coefficient for garage was positive 1. How would this change this model, and what room would have the highest now? So garage has a coefficient of positive 1. How would this change this model? So here's the equation for small bedroom items. And then what would change about this equation now? What would change? It would change the intercept only, exactly. And the intercept would go up by that much. And so this is what would change about the equation. And so now this would have the highest, just kind of basic sales and everything. Does that make sense, Ahood, right there? So the reason small has a, you could put in a medium level or stuff like that. So, but does this make sense how we're writing out these implicit lines? Because technically what we did is this became a 1 right here, and then we multiplied it. Yeah, really good practice. And so I kept everything else the same. I just really cared about the coefficient of it. And so practicing writing these is really good right here. And some of the easy questions I'll probably put on the test for 320 will be things like how many levels were there in the variable room? So the thing is, it looks so easy because if I give you the data right here and I say how many levels are there in the variable room, and I could just give you this output like this. I could say how many levels are there, and how many levels are there, Ahood? Boom, yes. Yes, you knew it. You knew it. You got it right there. Use Command Z or Control Z. Try Command Z or Control Z, Mackenzie. Don't close the computer. Use Command Z or Control Z to undo the delete. Try undoing the delete with Command Z or Control Z. Try to undo the delete. And Ahood, you're 100% right. And you see, I think a lot of people, like if people are not following along with the class, they'll look at it and be like, oh, there's 3 levels to the variable room right here. But there's not 3 levels, there's 4 because we don't see the reference. Yeah, which the last question on the homework? Is it the sugar content one? We just did sugar content one a moment ago. Do you want me to redo it? Is it sugar content or the bike routes? Are you saying like the last one like this? Are you saying we can do the bike route one? If you're here to sorry, I'm just gonna yawn the whole time. If you're here today, you get to ask the questions. So I'm more than happy to do questions. So someone's like, they didn't do a question. It's like, come to office hours. Come to office hours. We'll do a question. I never want to. I only tell people to watch a video if I'm like not teaching in that moment. You're welcome, Ahood, so much. When you get a chance for assignment 474 10.3 with classification, do you know why my code output is saying error input must be factors? I'm assuming electricity got loaded, right? I'm assuming because I know is an issue. Error input must be factors. It looks like you're using a quantitative Y when it wants you to use a categorical Y. Oh no, Gabby, we might have to hop on Discord here. I know I said that in the email, but when I'm done teaching here, I can hop on Discord with you, and we can try to get that fixed up. But we will try to do that. We really need to do like a stat to one wide, like Among Us. So awesome. Yeah, we will definitely take a look at that. Let's see right here. Let's try this last problem right here. One of these days. Oh my god, I'm gonna stop yawning into the microphone. Who else is just like winter break cannot get here soon enough? Winter break, where are you? So we have that they're going to drive the route 15 times. It takes 41 minutes on Route A and a standard deviation of 2 minutes. Route B takes 45 minutes with a standard deviation of 5 minutes. So notation. I need someone to help me out with at least one of the notations right here. I need someone to help me out with at least one of the notations. If you're watching this right now, try to do the notation on your own right here. Because from this, we're almost done with this. Once we get the notation, we're pretty good. We just need to do y bar b minus y bar a. That's the way they've set up the problem. Plus or minus t with degrees of freedom. And I think, yep. And then we'll call mean, like this will be mean A, this will be mean B, and square root S, whoops, even I'm making a mistake right here. S sub B, can do better on that, squared over S sub, oh my gosh, N B plus S A squared over NA. There we go. We got it. We got it. And you are right. This is sample size 1 and 2. So this is sample size B, sample size A. And this is, oh my gosh. Whoops. Standard deviation of route A. Mean of route B. Standard deviation of route B. There we go right there. Let's put in our numbers. And we'll find the t here in a second. The t is the hardest part of this problem. The t just makes it really not fun. Other than that, it's not a bad problem. There we go. So that's going to be very close to, okay. So now to find the t, you have to go and use the applet links we gave, 5 and 2. Okay, so the first thing we're going to do, so we're going to go over to this applet in the chat right here. We're going to put in sample size, standard deviation, and there's degrees of freedom. We go to the degrees of freedom now, and we go to the applet. We put in the degrees of freedom, and then we put in the percent confidence. I think it wants a 95% confidence interval, so let's go to a confidence interval. Put in 95%, and here's the t-score, 2.101. Does it want a 95% confidence? Well, we'll find out the hard way. 2.101. So you have to go and use both those applets. You have to find the degrees of freedom, which tells you which t you're going to use. And then from there, you can solve for the t statistic for a 95% confidence interval with the relative degrees of freedom that you found. The degrees of freedom just tell you which t you are using, and it's just a mathematical formula based on the standard deviations and the sample sizes. All we're doing is using this to compute the degrees of freedom to tell us which t we are using. As you can see right here, when we change the degrees of freedom, it changes the look of the t distribution. More degrees of freedom equal a more normal t, and here are our relative degrees of freedom, and then we put in a 95% confidence interval, and that gives us the t statistic, which is right here on the screen, the 2.101. And I think that's got it. We just need to solve this. That's going to be square root of 2. 2 times square root of 2. And so let's go right here. And 25 plus 4, there we go, divided by 15. That's that. Square root times 2.101. Got that. That is the margin of error. And this is 4. So it's 4 plus or minus this. 4 plus or minus 2.92. So 4 plus or minus 2.92. Let's make sure we got it. There it is there. And then 4 minus that is that right there, 1.08. And then 4 plus this, 6.92. And should the man believe the claim that it takes 5 minutes? Yes, because it's in the interval. We got it. Can you do the consumer spending question? Yeah, let's do the consumer spending one. But can you do the sports reporter question on the quiz? Yeah, sure. Let's do sports reporter and then we'll do consumer. So let's do sports reporter and consumer, whichever. Oh, we did this one. Does not say look at the answer. So that's whether the freezer method left fewer. So freezer method left fewer than the counter. Not do that one? Sure. So let's see which one we get first. Do consumer. So we got the consumer one right here. Awesome. So we're going to do the consumer one, then we'll find the sports one. Let's do it. Do consumers spend more on a trip to store A or store B? Suppose researchers interested in the question collected a systematic sample of 80 stores. So there's 80 stores from A and 77 stores from B. Customers, by asking customers their purchase in the stores, the data collected is summarized in the table to the side. It gives us the degrees of freedom, and it gives us what they tested the null at. So good stuff right there. We get the degrees of freedom. As soon as I get the degrees of freedom right there, I'm going to go to this applet, and I'm going to type in the degrees of freedom, which I think that's it. There we go. We're going to take these degrees of freedom right here and put them right into this applet. And that is what we should do with the degrees of freedom. Let's go ahead, drop this in the chat. There's the applet I am using to put my degrees of freedom into. Identify the null for this test and the alternative. Well, the null always has the equal sign. So they're going to see, suppose researchers decide to test the hypothesis that they are equal. So that is going to lead to the alternative that they are not equal. Computing the test statistic is going to be very similar to what we just did a moment ago. We just need to do it the following way. Let's go grab the data, bring it over here, drop it in, and write out our equation. So I think, are they testing, which way are they doing the test? Let me take a look. They're doing A minus B. That's very important. Okay. So when we write this out right here, we need to do mean A minus mean B over square root standard deviation of A squared over sample size A plus standard deviation of B squared over sample size B. And this is equal to the T with the degrees of freedom that they told us about. So let's go ahead and take and plug in our data right here. And when we plug in the data, let's see what we got. So we got mean 1, which is, or mean A, which is 40, mean 2, which is 52, and sample size A 80 and 77, and 20 squared over 18 squared. Okay, let's solve it out right here. Let's do this. Okay, 20 is 400, divided by 800, that's 5, and then 18 squared over that, divided by 77, and that's got it, plus 5, square root, and then we have this, 40 minus 52, divided by that, and there we go. There is the t-statistic, negative 3.95. And I should be able to guess the p-value from this. Negative 3.95, 2 decimals, the p-value is going to be 0. How many decimals? 3? Yeah, it should be about 0. And we are going to reject the null. There is evidence that the means are not equal. We got it. Let's explain how we got those last two parts so quickly, because you're like, well, how did you know the p-value? T-statistics and Z-statistics are virtually identical. T-statistics and Z-statistics are virtually identical. That means when I am doing a two-tailed test right here, a two-tailed, if I have a T-statistic of an extreme value like this that's very close to 4, the area on the outside is about 0. And you should know that if we have a T-statistic about negative 1, it'll be about 32%. And a T-statistic of about 2, it'll be about 5%. So you're seeing here the 68, 95, 99.7 rule coming into effect, where we see 68, 95, and 99.7. So the t-statistic with this many degrees of freedom is virtually identical to a z-statistic. And because we're at such an extreme t-statistic right here, I was able to say, well, then the p-value is going to be about 0. And since the p-value is 0, or virtually 0, we're going to reject the null because the p-value is lower than alpha. When the p-value is lower than alpha, we reject the null and we have sufficient evidence. The only two possible answers right here are reject the null, there is evidence, or fail to reject the null, there is not evidence. If the p-value was high, we would have picked this one right here for high p-values above 0.05 alpha. When the p-value is low, we reject the null. So make sure to take your t-statistic. You need to take this t-statistic and bring it over to an applet like this and do the two-tailed test. So I'll put this in the chat right here. But make sure to do the two-tailed test that you're seeing me do right here. Because if your t-statistic is smaller, like negative 2.34, you will get a p-value that is existing. You will get something bigger than 0. And I think that does it. That shows how, does that make sense right there, Kennedy? Does that help out? I know I did the last parts really quickly. It's just once we got the t-statistic, I was like, oh, it's a big t-statistic or an extreme t-statistic. Thus, I know the p-value is 0. And awesome. I think it's kind of nice when you get to these parts and it's like, okay, wait, I know this is a big t-statistic. And you can solve the rest by just using knowledge on how t-statistics work. A sports reporter, is that the, oh man, look at this. We're so close. We could just do the first ones again here. We'll done the whole quiz. A sports reporter suggests that the professional baseball players must be on average older. So they're saying that baseball's older than football. Researchers selected 32 professional football players and 33. You know what's so funny? My fantasy team is doing amazing this year. I got Brady. Brady's doing great. He had 1 or 2 bad weeks. Had some amazing weeks, but I've got Brady and I've got a lot of other really good players. So my team is crazy. I should show my team and see what people think about it. If someone's in here and wants to see my fantasy team, I'll show you my fantasy team. You can tell me good or bad. You can be like, you did amazing, Brian, or not. Suppose the researchers decide to test the hypothesis because they think it should be the answer to the first one, right? Let's see right here. They're saying if baseball players are older than football players, right? So baseball players are going to be mean 1. So they want to see if the difference is positive. And so this right here would suggest that this mean is higher because if the difference is positive, then mean 1 was greater than mean 2, and they're seeing if baseball players are older than football players. Okay, let's do this. So now we need to do the test. And the test, you know what we're going to do? We're going to go back over to one of our sheets where we were working on it, and we're just going to change the data. So if you notice right here, the formula, can I go back in time? Look at that, amazing. And so now we just need to plug in the numbers and solve it out. Cut it out. Cut it out. Old school memes. And let's go right here. Plug in baseball has a sample mean of this. Football has a sample mean of this right here. And we have the standard deviation of 3.86 squared over 33. And then we have right here 2.82 squared over 32. So this has got it. We now have the t, which is going to tell us how far these are apart. 3.86 squared divided by 33. Copy that. 2.82 squared divided by 32. And add these two together. And then square root it. Take the difference of the top two. I think I did it right. There we go. And that's close to 3. So this one's going to be interesting. 2.89. And it is a positive difference. That's going to be... So I can guess this one. It's actually going to have a p-value of probably that. Let's see. I think this is right. Let's see if I got it right, and then we'll check. We are going, since our p-value is low right here, and let me show how I got it. This one is going to be a little bit more complicated because we need to go and take, and I've got a screenshot, that's good. So let's go and check it, because I'm 99% certain, more than 99. I've done a lot of these problems, if you can't tell. So we need to put the sample sizes here, 33 and 32. And then we need to put in the standard deviations of 3.86, 2.82. 3.86, 2.82. Degrees of freedom are 58.6. So we go over here and put in degrees of freedom 58.6. And then we do a right-tailed test, and we take our t-statistic, and we put it in there, and the p-value, ooh, I wonder if I would have gotten it right. It's 0.003. And we have the links in the chat. The first one you want to do is go over here to the degrees of freedom, calculate those. And the second thing you want to do is go to the t-statistic, or go and put in your t-statistic, and it's a right-tailed test, 0.003. Ooh, I don't know if that would have done it. Let's put in the right answer first, and we are going to reject the null hypothesis at the 0.001 alpha level because our p-value is lower than that. There is evidence. We reject the null. There is evidence that the baseball players are older, and we did get it. And would we have gotten it if we did that? We would not have. Ooh, my guess was not right. Is there that much leeway? Okay, there is. I was off by a thousandths. So I was off by a thousandths right there. Had I put in the answer I thought was right, we would have been off by the tiniest of amounts. But once again, use these applets. You can kind of take guesses, but I was like, ooh, that's a little bit more off than I thought it would be. And we got the right answer right there. Ooh, almost missed one right there. We almost missed one. So this is the first one we started out with. Mubot, you're repeating yourself. You okay, Mubot? You okay, Mubot? Oh, wait, it's repeated 3 times now, Dan. Let me reset Mubot. Mubot's having one of those days. I think Mubot needs coffee. I need coffee. Mubot needs coffee. Mubot's crashing the stream right now. So you too, Dan. We'll finish off the last few questions right here for fun. If you notice right here, this interval is positive. We did this one at the start. We went more in depth. We're just going to kind of clear the whole quiz right now. And we might hop off and take a little bit of break and respond to some emails and some Discord messages. So you see right here, the whole interval is positive. Since the whole interval is positive, that means that the mean for meat was higher than the mean for beef because the mean for meat is the first one, and we have here that we have a positive difference. So it'd be like 10 minus 6 is positive, but if it was 6 minus 10, that'd be negative. So it's probably that the mean for meat is higher, and since 0 is not contained, we have evidence of a statistically significant difference. And if you want a more in-depth talk on this, we went more in depth at the start of office hours on this. Do we still have that sheet up? We don't. What a bummer. We went more in depth at the start of office hours on this. Ooh, look at that. It's trying to trick us. We click back on here. And last but not least, we have some stuff on the margin of error right here. With the margin of error right here, the margin of error is half the length of the interval. So we go here and we take half the length of the interval. And here's half the length. There's the margin of error. If we went from a 98 to a 95, it would be smaller because we're going to decrease the critical values, which makes the margin of error smaller, and everything gets smaller. We are 98% confident that the true difference between traditional and non-traditional students is going to be that non-traditional students, a plural, score about this much higher. So the non-traditional are going to score that much higher, and it's going to be the students, the non-traditional students. And does this suggest that the students in the non-traditional learn better? Yes, because 0 is not contained in the interval. It's entirely above it. This is strong evidence, and we did it. We have now gotten 100 on every question. We have completed the whole homework, the whole quiz. What other questions are there? 320, 474, let me know. Dan, if you're still here, we could talk about some chi-squared. I don't know if anyone's here. We went a little long yesterday. We might go short today. We'll see what people say. But we've done the whole assignment. We've done every possible question. All questions completed. Every question completed. Gonna get some water, get a little lunch. Well, with that, if you are here right now and you have questions, how many people are watching? Let me go. I'll see like one person's watching. I'm like, no. No. 5 viewers. 5 viewers. We have completed the whole homework, the whole quiz. If you have questions, let me know. I'm going to hop around using this as a background noise. Oh, man, that's awesome, Charlie. We did everything. We have done all chapter 17, the whole thing. And good luck with econ, Charlie. Keep up the great work. I love it that and the YouTube channel is getting about 2,000 views, or excuse me, 1,000 views a day. It shows it in 48-hour periods, but we're getting about 2,000 views every 48 hours. So it's pretty cool that, daily we're getting almost 1,000 views these days. So, good luck with that exam tomorrow. But people are using the content, people are watching it, people are reviewing, people are hopefully learning the material, and that's my goal. That is my goal, to keep putting out live material and all that stuff. But we're going to try even harder next semester to get more people watching live. But I really appreciate it. Don't worry if you're not watching live, I understand. People have jobs, people have work, people have kids, people have, a lot of stuff going on. Chapter 17 today. Yep, we did all of chapter 17. The whole entire thing. Everything was done. Chapter 17 is due when? Is it due today? All of chapter 17 was completed. All of chapter 17 was completed. It's due tomorrow. We are way ahead of schedule. We got it completely completed. Whole thing done. Just got to practice makes perfect. And then we're going to finish up the last big chapter today for 201. And I'm just excited. I am excited. In class today, we are going to do chapter 19. Class today is about chapter 19. Chi-squared test of independence today. Class today is chapter 19. With that, any additional questions right here before I head off, run around, do some stuff, get ready for class? The new visualization assignment's out. The new visualization video's out. With that, I think that'll do it. You don't have any? Awesome. Well, with that, everybody, I'm going to head off. I'm going to go grab some lunch, maybe make a sandwich or something. I'll talk to everyone later. See 201 in a little bit right here. So bye for now. Bye.